One sample t-test. One sample t-test, z-test, and t-test. Z-tests are commonly done when the population standard deviation is known. T-tests are commonly done when the population standard deviation is unknown. We use the t-distribution because the unknown population standard deviation is now a value we must estimate. First example, in the population, the average IQ is 100. A team of scientists wants to test a new medication to see if it has either a positive or negative effect on intelligence, or no effect at all. A sample of 30 participants who have taken the medication has mean of 140 with a standard deviation of 20. Did the medication affect intelligence?
Step 1.
Our alpha is
Define our null
0.05.
hypothesis. Then
These
state
are
the
the
alpha,
steps. First, define the null.
calculate the
State the
degrees of
alpha.
freedom,
Calculate degrees
state
of
the
freedom.
decision null,
State decision
calculate
rule.
the state statistic,
Calculate test statistic.
state result, and
State a
state
result.
conclusion. So
State
let's get started.
conclusion.
Our HO is 100 because the
These are null
population,
and alternative hypothesis.
the average IQ is 100. Second, state the alpha 0.05. Third, n minus 1 is equal to 30 minus 1 is equal to 29. We had 29 degrees of freedom and our alpha level is 0.05. And our critical value is 2.0452. So our state decision rule is if t is less than negative 2.052 or greater than 2.052, our null hypothesis will be rejected. Calculate state statistic. Sample mean is 140, population mean 100, sample standard deviation 20, sample size 30. Then substitute, then we will get 10.96. Our state results. Our decision rule is if t is less than negative 2.052 or greater than 2.0452, our null hypothesis will get rejected. And we found it 10.96. So 10.96 is greater, so that it will get rejected.
Conclusion, or what this means, is that medication significantly affected intelligence. Basically, it did something. It changed it from the expected value of 100. In this case, it was 140, so it looks like it went up a lot. We can't really say that, but it is different from the 100 we thought it would be. And then I have t equals 10.96 with p less than 0.05. That's just the official format for stating the results. If your teacher wants you to do that, you can do that. If you don't, then you don't have to do that. But that is how you would write your conclusion. And that is a one sample t-test.
T is a statistic. X sub 1 is the average for men, equals to 9. X sub 2 is the average for women, is equal to 12.
N sub 1 is the number of men who provided a response to the NPS question. To say 20 men responded to the survey, N sub 2 is the number of women is equal to 23 women responded. N sub 1 is the standard deviation of the NPS for men. Say the calculated standard deviation is 12.48. S sub 2 is the standard deviation of the NPS for women. The calculated standard deviation is 10.51. Then we will substitute square root of 20 minus 1 times 12.48 squared plus 23 minus 1 times 10.51 squared over 20 plus 23 minus 2 is equal to 11.47. According to this table, for our two-tailed test with an alpha of 0.05 at 41 degrees of freedom, the critical value is 2.02. This is our second example. Then we got 5.93. Third example. First is to define the null. Next is to state the alpha, which is 0.05. Then calculate the degrees of the freedom. The formula is n sub 1 minus 1 plus n sub 2 minus 1. Then we substitute, which is 25 minus 1 plus 20 minus 1 is equal to 43. Then we will state the decision rule.
Last example is first we define our null hypothesis, then state the alpha, calculate the degrees of freedom, state the decision.
Then we calculate the state of statistic, which is df sub 1 is equal to n sub 1 minus 1 is equal to 25 minus 1 is equal to 24. Then n sub 2 minus 1 is equal to 20 minus 1. Substitute that. We substitute it, then it equals to 19. Then the lower part, we multiply it, then we got 5,400 and 11,875. Then use the information to calculate the pooled variance. We've got the formula, then substitute 5,400 plus 11,875 over 24 plus 19 is equal to 401.74. Then we finally get our t value. T is equal to open parenthesis 70 minus 74 close parenthesis over square root of 401.74 over 25 plus 401.74 over 20. Then we got negative 4 over square root 36.16. Then negative 4 divide square root of 36.16. We got negative 0.67.
Then we will state the result.
T is equal to negative 0.67. Then our result, the null hypothesis will not reject. Then lastly, we will state our conclusion. There was no significant difference between the test performances of Class A and Class B. T is equal to negative 0.67 and P is greater than 0.05.